Hey guys, I'm Nick and welcome back to my channel where I post all the cool stuff about Houdini, C4D, Octane. I even tried Redshift for the first time in my life and I got to admit I love that. But that will be in next tutorials. So for now, I found this amazing piece by onandon, onandon, or more and more studio, and I really wanted to recreate that in Houdini and see how it's done, or just like try to come up with my own solution. So in today's video we will be checking out this piece. But before we start, as always, I want to say a huge thank you to everyone who supports me buying my project files, assets. They're pretty cool flower and coral asset packs, and all the videos you see in my channel. I have project files available for download, so if you find my tutorials useful, please support me by purchasing them. And alright, let's start with our clause expansion thingy. So don't be afraid, I will go node by node and explain what's going on. So here we have this tube. It's a primitive type set to polygon. It's centered a bit above the 0, and these rows and columns, you see the green expression kind, but expression is any sort of algorithmical or mathematical functions. So basically multiplying values, multiplying numbers. Houdini counts that as a sort of expression. Here, why we are using these 4 and 2 is just for me to easier can maintain the ratio. So I want these to be kind of like a square or something. And for the purpose of this tutorial and fast responsive feedback from Houdini, let's do it like 70 rows and 150 columns. So then I UV unwrapped all the default settings, but this UV unwrap is absolutely unnecessary because if you attach a texture and you don't do the UV unwrap, and when all the volume expands, your texture will just like float on the surface, like swim away, or like basically it won't be attached to the geometry properly. And then we need some sort of geometry to actually keep our vellum in place, because we will have gravity, and without that it will just like fall to the endless bottom of the scene. So yeah, we do need to add a tube. We poly extrude it, and then I just remeshed it, so we have more points attached to the points of our volume tube. And here's our group. These are our points. Now we will need to check the attributes, because what we are doing here, we will need to somehow paint out areas that will be expanding. And here, let's say I will need to colorize everything to black, and black is a great color because the values of the RGB is 0, 0, 0. And then I can grab a sphere and I can set it transform. And here you can see that I also transformed the pivot. So it's basically, it rotates over the time around the tube. And here you can see a little expression. So basically I set it up here, and then every frame it goes frame number multiplied by 3. So at frame 1 it's 3 degrees, at frame 2 it's 6 degrees, at frame 3 it's 9 degrees, plus 90 of course every time. And I colorized the ball to be red, and value of the red is 1, 0, 0. So basically here in attribute transfer we set the attributes, color attribute CD from points, we set it to be transferred from our red sphere to our black volume base. And what we have here is, you see, as we rotate our sphere, you see that we are transferring the attributes, but the problem is right now we don't keep the attribute. And here I found this super helpful YouTube tutorial by Terra Animator. Here's the link to his YouTube tutorial, and basically we are using solver, and don't be afraid because it's really easy one. We increase the substeps to be 2 for starters, and then we go inside the subsolver. So this is actually like a default. You will have all these nodes here. We need to grab a switch and then attach our input frame and the previous frame to the switch. Basically, previous frame is your previous frame and input frame is the current frame. For example, right now is the frame number 1. And then we drop an attribute wrangle and plug the switch to the first input and the previous frame node to the second input. And here we are basically comparing the values, the color values. So we will need to get a vector, let's call it like previous value. Then we wrangles go through all the points. So basically we write point attribute 1, and 1 specifies the input. So previous frame goes into input number 1, all good. We type attribute name, which is CD in this case. Then we write a point number, and ptnum is basically the point that is checked by attribute wrangle at this moment, and 0 is just a success callback, so don't worry about that. And then we compare if this point's red value is less than it was in the previous frame, we just set that value to that point, and magic happens here. So this is an expression. So basically what we are doing here, it's really an easy one, and it works only for the first frame. So and it tells basically that if our current frame number or our current frame is bigger than 0, or we don't have any previous frames, we will use current frame. If nope, we will read the data from the previous frame. That's all it does. So basically, see, at the first frame we have the input this at 0, and anywhere over that first frame we have input 1. So this cool little trick, again, huge thanks to Terra Animator. And now if we enable our solver, you will see that we keep our transferred attributes. And here I just wanted to remap the attributes, and first of all we need a rest scale for the volume, and I figured out that for this example it works good when we have the minimum output value 1 and maximum output value 7. And we also need stiffness, so minimum output will be 100 and the output will be 0.5. Don't ask me why it's like that. And then we just drop a null called parameters, which stores all the attributes, so m rest scale and m stiffness, and m stands for my or something like that. So now when we have this setup ready, our attribute transfer setup ready, and it's working, let's actually set up some Vellum. For example, we will need Vellum constraints. Drop it first, and here we set the constraint type to be cloth, mass to calculate varying, thickness to calculate uniform, pinpoints should be this group, and in my case it's called attach. And oh yeah, and bounding type is set to bounding object. So basically what we feed here into the second input, it will be our bounding object. So yeah, here we have pin to animation, attach, pin type permanent, stretch, set damping ratio to be 0.1, and in bend set stiffness to be 10, but multiplied by this 1 millionth. So what do we have here? Nothing. All good. Now we go to the Vellum solver. So here let's set our constraint iterations to be 300, substeps to be 4. And why I am doing that is because we have a pretty rapid expansion of the volume of the cloth. and it may result in some odd or weird behavior because we are expanding the cloth that quick. So that's why we will need around 4 substeps. And for collisions, yeah, ground collision at minus 3.5, just because we will have this, all this beauty volume, not volume, but vellum. So yeah, we will have that expanded, and I just want some wrinkles here. And rest post collision passes to be 7, forces, gravity minus 10, velocity damping 0.1. I think all the other stuff is default, and it won't work if we don't go inside the Vellum solver. And here let's add some cool stuff. So what do we have here? We have our Vellum constraint properties node, and we just want to target one group. It's called stretch, and it is here, the Vellum constraints, this stretch. You can take this output group, it will be called stretch. And yeah, we are just targeting the stretch factor, right? We are not targeting the band. So let's go inside Vellum solver again, and for the inputs, we will need to pass our parameters into the Vellum constraints properties. So for this input number 3, you can select SOP here and select our param node, which stands for like parameters. So now we tick enable the stiffness, we enable the rest length scale. Stiffness you can leave it once, I think, because we are overriding it with our vex. Alright, so what we are going to do here? So we need an attribute, and you can just write like, you can just do something like this, but it's more clear if we actually declare our variables. So float mRest scale equals point, and it is equal to getting point attrib like we did before, but yeah, just a bit easier. So we type down point, second input, and our second input, here it is input 3, but basically it goes 0, 1, 2. So our second input, our params null, we want to get the mRest scale attribute, and then for the point number, like current point number, so ptnum. And then we assign rest scale to, and then we assign our mRest scale here. We assign that to our actual rest scale, and rest scale is this one, rest length scale. If we hover on it, you will see the parameter name is rest scale. And same goes for the thickness. So not the thickness, sorry, stiffness. So m stiffness equals same param null, and we get our m stiffness on the current point, and then we assign our stiffness to stiffness. But in this example, I needed to divide it by 100, just so it works. Here in the pop wind, just a tiny bit of wind, nothing crazy. Everything default, amplitude set to 0.5. Let's see how it goes. So here you see that we are rapidly expanding the cloth, and we might have some strange things going on, but that's why we need more rows and cells, so it's actually a bit smoother than it is. So let's see where we got. Now it looks weird, and I know. Just wait for it. So what we need to do is, actually you need to set these to what it was, like 2 and then 4, I think. But anyways, I've set the Vellum pack, then I cached it to the disk, and then set a Vellum unpack. So it looks like this. This is with the like crazy dense geometry. And actually, then I dropped a Vellum post process node and subdivided it even more. And yeah, in result you will have a pretty dense mesh, but come on, we want good looking result, right? We don't want like any sort of, I don't know, protruding polygons or rough edges, all that stuff. So I added a bit of spatial blur, subdivision method set to Catmull Clark, subdivision depth set to 2, thickness is set to 0.1 because yeah, we need that thickness just a tiny bit here, right? After that I added normals, and after that I added time warp, and in time warp I believe I set it to, yeah, to half of its speed. So actually it's a good practice to basically, you know, you simulate like, I don't know, 100 frames, and then you slow it down to, let's say, 0.5, and you have actually a like good looking slow-mo simulation. Yeah, I do that pretty often. And then we dropped an ROP alembic node and output the alembic for 420 frames. Remember, we did just 210 frames of simulation, and then we get our output of 420 frames. That's it for the Houdini part, and let's open up Cinema 4D. And again, why I am not rendering that in Houdini, just because setting up materials in Houdini, in Octane Houdini, for me, it's an actual nightmare. It's so much faster to do in Cinema 4D or even in Blender, I don't know. Maybe I'll change my mind when I will be working with the Redshift, but for now, I really stick with this workflow when I do some simulations in Houdini, and then I export that for Cinema 4D to actually make any sort of a composition or 3D scene. Alright guys, so here we are in our Cinema 4D, and with our Octane Render settings are best tracing kernel 1000, max sample diffuse specular scatter depth set to 8, caustic blur set to 0.5, GI clamp set to 6, and we're using just, yeah, 3 materials and 3 light setup. So yeah, this one, that's the ground. Let me turn off the camera. So this is how it looks. Basically 3 lights and backplate or something. I actually, not like I removed the rim, but I think, yeah, I removed the rim. That's why, yeah, I attached to rim, black plastic on it. And this one, that's a leather material. So let me show you that how it looks. Here in the light, 3-point light system. Top light, fill light, and key light. Actually, top light, fill light, and then key light. I also love to tweak the camera settings, and I was like going back and forth with I think this, no, yeah, this one, this makes more drama, and maybe this one, but yeah, went with this light setup. So in the camera settings, in the camera image, or exposure is turned up to be 1.125, gamma 0.71, highlight compression 0.23. I think that's it, yeah. So yeah, and we have this cool little animation. So that's it for today guys, and thanks a lot for watching. As always, all the files for this project are available on my Gumroad, first link in the description. If you enjoyed these tutorials, please consider subscribing to my YouTube channel. I will be posting new tutorials every week, and if you want to support me, feel free to check out my Gumroad store. Bye!